I'm a bit sick today, so bear with my voice, but we are going to be discussing the discriminant today. And what is the discriminant? Well, the discriminant is a derived form of the quadratic equation, which we've discussed before. Previous very well, we've just touched on it. And the quadratic equation is minus b plus minus, and it's in what you call it, root b squared minus 4ac. I mustn't forget to put this all in brackets. And then all of this is over 2a. Put this in brackets again. I think I should get the job done. Okay. So that is the quadratic equation. Let me just put this 2a in brackets, just to make that look a bit better. There you go. That we've used before. And this is used to discover the roots of any quadratic equation. And today we're going to be discussing the discriminant, which is just a shortened version of this that doesn't give us the exact values, but it does give us some information. And the discriminant formula is simply b squared minus 4ac. So b squared. Right. And you can see here that this is just what's in the brackets above the in the quadratic. It's what's under the root. And what does this tell us? Well, it can tell us a couple of things. It tells us mainly the nature of the roots. So what are we dealing with when you're using the quadratic equation without using the quadratic equation? Well, we have a few scenarios. The first scenario is when b squared minus 4ac, sorry, just add another line. B squared minus 4ac. And we have when this is equal to 0. Now, when this is equal to 0, it means that there's a singular repeated root. So that's when you'll see x minus 3 squared, and that would be your root. So x would just be simply 3 and 3. There is no second root, it's just 3. Okay, and then we've got two other scenarios. In general, we've got b squared minus 4ac is greater than 0. And when b squared minus 4ac is greater than 0, that means that there are two roots. Okay. Right. So this means that it could be x minus 3 in brackets, and then open brackets again, x minus 5, and then your roots would be x3 and 5. These are just an example. But when this is above 0, meaning it's non-negative and it's not equal to 0, then there will be two roots. Now, when b squared minus 4ac is less than 0, it simply means that the equation doesn't have any roots. Now, why is this? Well, it's because when you take where this is from, right? It's from the quadratic equation up here. It's from this root here, b squared minus 4ac. And if there's a negative in a root, it's a non-existent number. It doesn't exist, right? So it cannot be negative, therefore there will not be any roots in this equation. So to visualize this for you, we'll put up in Paint here. And let's draw some graphs, just hastily drawn graphs. Yeah. And we'll just draw 3 graphs. And this one here will be equal to 0. This one here will be greater than 0. And this one here will be less than 0. Okay. So what does this look like? Well, this one here means there's only one repeated root. So the graph might come down here and just touch the line and come back up. Just at one point it's touching the line. Here it's greater than 0, right? So it has 2 repeated roots, which means it has 2 points that it crosses over there and there. Let's put another line here just to say that it only crosses there. And when it's less than 0, it means it doesn't touch the x-axis, because remember, that's what an x is, what a root is. A root is just the intercept of the x-axis. So here, when it's less than 0, it doesn't touch at all, which means it just lies above the x-axis, never touching. So that's basically just what the discriminant is able to explain about the nature of the graphs. We've done things to see where the graph lies, the shape of the graph, that sort of thing. Now we're getting more into what happens when you want to know more specifics about it, And this allows you to work with some previously unknown information. So, for instance, we're going to go through a couple of equations. I'm just going to do all this quickly. Okay, so we're going to go through a couple of basic examples. So let's take a normal one, and they're going to ask you to find how many roots there are in this equation. It's got x squared minus 3x, sorry, it's bad on x, minus 5, right? And they're going to ask you how many roots are in this equation. All you need to do is simply plug this into the b squared minus 4ac, so b squared minus 4ac, and in this case b squared is minus 3 squared, which is 9, right? So 9 minus 4 times ac, which is 1 and negative 5, so 1 times negative 5, which ends up being 9 minus 20. Sorry, 9 minus 20, which is 9 plus 20, equals 29. Now this number doesn't really matter. All that matters about it is what is the sign in front of it. Is it positive? Is it negative? What is it, right? Or is it 0? So in this case it's positive, therefore there are 2 roots. Okay. Let's do another example. I'm going to go x squared plus 2x plus 1, right? And in this example, again, we're going to go b squared minus 4ac. So 4 minus 4, 1 times 1. So that's 4 minus 4, which is equal to 0, right? And what happens when it's equal to 0? Well, that simply means there's 1 root that it has been repeated. And you can go ahead and you can just expand this out into its factorized form, and you'll see that it's just x plus 1 plus 1, and it's just x plus 1 squared in brackets, which means it's 1 repeated root, right? Okay, let's go do the last example. Okay, and that's x minus 3x plus 4. Okay, and in this case it's going to be b squared minus 4ac again. So 9 minus 4, and then 1 times 4. And you can see here this is going to be 9 minus 16, and that is a negative number. Right, so 9 minus 16 is negative 7. And negative 7 being negative means that there are no roots. This is because, again, in the square root, negative cannot exist. You cannot have a negative under the square bracket. Now let's get into a bit of a more complicated example, and it's one that allows you to glean a bit more information from something. So what they might ask you to do is they'll provide you with a little bit of information. They'll say there is a repeated root in the equation. Find the value of the unknown. So let's take an equation here. X squared plus 3x, and I'm going to go minus k. Now, because they've given you the information that there's a repeated root, that means you know that the equation is equal to 0. And when this is equal to 0, sorry, not the equation is equal to 0, the discriminant is equal to 0, right? So how do we solve this? Well, we'll go back to exactly what we did before. So it's plus 3, so it's b squared, which is 9, minus 4ac, right? In this case being 1 is a, and c is negative k. Okay, which goes out to be 9 plus 4k. And we can say this is equal to 0. And from here, it's simply putting it along the line. 4k is equal to negative 9. And then from there, you can say k is equal to negative 9 over 4. Right? Be careful when the k is squared or anything like that to always add the plus minus here, so squared or squared root. just because remember there's always two answers for that. But in this case here, you can see we've been able to solve what negative k is here without any other assistance, right? They've only given us the information that it's equal to 0. And you can do this with any of the values. They'll say if there's two roots, then you just say it's greater than 0, and if there are no roots, then you say it's less than 0, and that's all you put the equation to. See if I can just. Right, and let's just do another example here, moving the k. So kx squared plus 5x minus 8. And again, the root is repeated, so the discriminant is equal to 0. So b squared, 25, minus 4. In this case, a is k, and c is negative 8, right? So it's going to be 25 minus plus 32k equal to 0. So 32k equals negative 25. K is equal to negative 25 over 32, right? That's just an example of how we can move the k in any location here, and it doesn't really matter. The discriminant will allow you to do it as long as you have the prerequisite information of how many roots there are. Just open a new file. So right, and let's do one last example with k. So let's go negative 2x squared plus kx, and you can see we've moved the k along every time. Minus 3, and again repeated root, so the discriminant is equal to 0. So we can go b squared, which is in this case k squared minus 4ac is 4, a is negative 2, and c is negative 3. Right, so this is going to be k squared minus, k squared, yes, minus 4 times 6, so minus 24 is equal to 0. So k squared is equal to 24, negative 24. Oh, no, that's positive 24, sorry. Right, and then you can obviously say k is equal to root 24. But here you'll remember have to say plus minus. And because this is in a surd, remember surds are non-normal values. So normally something like this with the root in it, you can simplify a bit more. 24 is very easy to simplify. So k is equal to plus minus. And if you simplify the surd, goes into 2 root 6. All right, that's in the surds video that we'll do. And there's a plus minus 2 root 6, right? So this is what I'm saying again earlier. You need to remember to add the plus minus because there's a root in here, so this root could be either positive or negative. And that's all you really need to know about the discriminants. And this is how it's used. It's just used to find the nature of the roots of an equation. And it can sometimes help you with a little bit more information. Right, thank you.